Hello, good morning viewers. So far you have seen how to expand binomial terms using Pascal's triangle. We have seen how to expand them, how to find the n term, and also how to find the coefficients of binomial expansions. So in today's tutorial, we are going to learn how to expand binomial terms using the general formula that involves series of combinations. All right. Suppose we wish to expand a plus b to the power of n. This is as simple as taking the summation of n combination r, a raised to the power of n minus r, then b raised to the power of r. There is a multiplication between these three terms, where r goes from 0 down to n. In order to take this series, we're going to be increasing the value of r from 0 down to n. As soon as it gets to n, we stop. So this is equal to n combination 0 when r is equal to 0, a raised to the power of n minus 0, which is the same thing as n, then b raised to the power of 0, which is the same thing as 1, then plus, you increase the value of r, we have n combination 1, a raised to the power of n minus 1, then b raised to the power of 1. You add n combination 2, a raised to the power of n minus 2, b raised to the power of 2. This is how you keep on going till you reach the last term, which is n combination n. As r is equal to n, a raised to the power of n minus n, then b raised to the power of n. You know, n minus n will be 0, so in the last term, a will be to the power of 0, which is the same thing as 1. And one thing you should know is that n combination r can also be written as n combination r, which is defined as n factorial divided by n minus r factorial, then r factorial. So this is the definition of combination. So now let us take some problems at random, like 2 or 3. Number 1, suppose we want to expand a plus b raised to the power of 3, for example, where our n is equal to 3 in this case, so we have only 4 times. So this is equal to 3 combination 0, that's the first time when r is equal to 0, a raised to the power of n minus 0, then b raised to the power of 0, plus 3 combination 1, a raised to the power of n minus 1, that is 3 minus 1 equal to 2, then b raised to the power of 1, plus 3 combination 2, a raised to the power of n minus 2, that is 3 minus 2, which is equal to 1, then b raised to the power of 2. And the last one, let me bring it down, 3 combination 3, a raised to the power of n minus 3, that is 3 minus 3 equal to 0, then b raised to the power of 3. So one thing you should observe is that the value of r will always be the power of b. Can you see that? When r is 0, b has a power of 0. When r is 1, b has a power of 1. When r is 3, b has a power of 3. So now let us simplify this. This is equal to, 3 combination 0 will be 3 factorial divided by 3 minus 0 factorial, then 0 factorial. Then we have a raised to the power of 3 minus 0, which is the same thing as a raised to the power of 3. Then b raised to the power of 0 is 1. So multiply by 1. You take the next term. 3 combination 1 is the same thing as 3 factorial. Divide by 3 minus 1 factorial. Then 1 factorial. Then a has a power of 2. B has a power of 1. You don't even have to write power of 1. Plus 3 combination 2 is the same thing as 3 factorial. Divide by 3 minus 2 factorial, then 2 factorial. A has a power of 1, B has a power of 2. Then the last term, 3 combination 3, that is 3 factorial, divide by 3 minus 3 factorial, then 3 factorial. A has a power of 0, so it becomes 1, and B has a power of 3. So the next thing to do here is to simplify. And remember that 0 factorial is equal to 1 factorial, and all of them are equal to 1. So let's begin. This is equal to 3 factorial to the top. Divide by 3 minus 0 factorial is 3 factorial. Then 0 factorial. We have a to the power of 3 times 1 is still a to the power of 3. Then plus, we have 3 factorial to the top. Divide by 3 minus 1 is 2 factorial. Then multiply by 1 factorial. A to the power of 2, b to the power of 1. Plus 3 factorial. Divide by 3 minus 2 is 1 factorial. Multiply by 2 factorial. A with power of 1, b with power of 2. Plus the last one, 3 factorial. 3 minus 3 is 0 factorial, then 3 factorial. 1 times b to the power of 3 is b to the power of 3. Let's further simplify this. We can cancel something here because 3 can cancel 3. I remember that 0 factorial is equal to 1. So from the first term, we only have a to the power of 3 plus the second term. The second term, we have 3 factorial divided by 2 factorial. Remember, 3 factorial is the same thing as 3 times 2 times 1. And 2 factorial is the same thing as 2 times 1. 1 factorial is also 1. So you can see that 2 times 1 is 2. And 2 times 1 times 1 is 2 also. So we have only 3 there. So we have 3a squared b. Then moving on to the third term, which is this. We have 3 factorial divided by 1 factorial times 2 factorial. Look at the coefficient, they are exactly the same. So we have 3ab to the second power. 3ab to the second power. Then the last one, we have 0 factorial is the same thing as 1. So this 3 factorial will cancel 3 factorial. What we have is only b to the power of 3. So we have b to the power of 3. So this is just the expansion of a plus b raised to the power of 3 using combinations. Now let us take another question. Example, suppose we wish to expand 2x plus 3 raised to the power of 4. Let me come down here. This is equal to n is 4 here. So we have 4 combination 0. Our a is 2x. So we have 2x to the power of n minus 0. 4 minus 0 is 4. Multiplied by b is 3 to the power of 0. Because remember, I told you the value of r will always be equivalent to the power of b. You take the second term, 4 combination 1 a, which is 2x, to the power of n minus 1, that is 4 minus 1 is 3. Then b will take that value of r, which is 1. So 3 raised to the power of 1 plus 4 combination 2, a, which is 2x, raised to the power of n minus 2. 4 minus 2 is 2. Then our b is 3 raised to the power of 2 plus 4 combination 3, a, which is 2x, to the power of n minus 3, that is 4 minus 3 is 1. Then b, which is 3 raised to the power of 3. And the last term, we have 4 combination 4, 2x to the power of 4 minus 4 is 0. Then b, which is 3 to the power of 4. So now let us simplify this. And there's something I wish to tell you. N combination 0 and n combination n are all equal to 1. So if you simplify this, you have to get 1. Likewise this, 4 combination 0 and 4 combination 4 are all equal to 1. I have proven that for you. From here you can see this will cancel, and last one you can see they will cancel. So we have no problem with 4 combination 0. We can just write the values. 2x to the power of 4 will be 16x to the power of 4. Already 3 has a power of 0, which is the same thing as 1. So we have 16x to the power of 4. Then we move to the second term. Let me simplify it to the other side. We have 4 combination 1, which is the same thing as 4 factorial. Divided by 4 minus 1 is 3. So we have 3 factorial. Then 1 factorial. This is the same thing as 4 multiplied by 3 factorial, because I have 3 factorial to the bottom. So they will just cancel. Times 1 factorial. This will cancel this. Already this is 1. So we have 4 there. And that 4 will have to multiply 2x to the power of 3, which is 8x multiplied by 8x to the power of 3. Then multiply by 3 to the power of 1, which is the same thing as 3. Plus 4 combination 2. Let me simplify it here. It means 4 factorial divided by 4 minus 2, which is 2 factorial. Then 2 factorial. This is equal to 4, 3, 2 factorial, because I have 2 factorial down here. 2 factorial. And 2 factorial is 2. This will cancel this, and 2 can go into 4 2 times. All we have is 2 times 3, which is 6. So 4 combination 2 is 6. Then 2x to the power of 2 is going to give us 4x squared multiplied by 4x squared. Then 3 squared is 9. Then we move to 4 combination 3. 4 combination 3 is 4 factorial divided by 4 minus 3 is 1 factorial. Then the 3 factorial. This is equal to 4 multiplied by 3 factorial divided by 1 times 3 factorial. So this will cancel this. We have only 4. So we have 4 here as 4 combination 3. Then 2x to the power of 1 is 2x. Then 3 to the power of 3 is 27. So we have 27. Then the last term, already I told you 4 combination 4 is 1. So we have only 2x to the power of 0, which is 1, multiplied by 3 to the power of 4. And 3 to the power of 4 is equal to 81. So the last term is just 81. So let's further simplify this. Our first term is 16x to the power of 4 plus. Now we have 4 times 8 times 3, which is 96. So we have 96x to the power of 3 plus. Again, we have 6 times 4 times 9. 6 times 4 is 24. Then 24 times 9 is 216. 216 x to the power of 2. then plus. We have 4 times 2 times 27. 4 times 2 is 8, and 8 times 27 will give us 216. So we have 216 x to the power of 1. And lastly, we have just 81. So this is just the expansion of 2x plus 3 to the power of 4. Now let us take one more question. Suppose we wish to expand maybe x minus 2y to the power of 3. This is equal to 3 combination 0, a, which is x, to the power of n minus 0, that is 3 minus 0 is 3, then multiply by also negative 2y, which is our second term, raised to the power of 0. You take the second term, which is now 3 combination 1, then a, which is x, to the power of n minus 1. 3 minus 1 is 2. Then multiply by the second term, 2 negative 2y to the power of 1. Then plus 3 combination 2, x to the power of 3 minus 2 is 1, then negative 2y to the power of 2. Then the last term, we have 3 combination 3, x raised to the power of 3 minus 3 is 0, then negative 2y to the power of 3. Let's simplify this. Remember I told you n combination 0 is 1, therefore 3 combination 0 is 1, and also n combination n is 1, so 3 combination 3 is 1. So from the first term, we know that this is equal to 1 as well, because any number to the power of 0 is equal to 1, except if that number is 0. So we only have x to the power of 3. So this is equal to x to the power of 3, then plus. What we have here is 3 combination 1, which is the same thing as 3 factorial. Divide by 3 minus 1 is 2 factorial, then 1 factorial. If you simplify this, you have 3 multiplied by 2 factorial, divide by 2 factorial times 1. 2 factorial will cancel 2 factorial. 3 divided by 1 is 3. So 3 combination 1 is 3. This draw our attention to n combination 1 is always equal to n. So 3 combination 1 is equal to 3. And we have multiplied by x to the power of 2 is x squared, multiplied by negative 2y to the power of 1 is negative 2y. We take the next term. That is when we have 3 combination 2, 3 factorial, divide by 3 minus 2 is 1 factorial, then 2 factorial, which is equal to 3 multiplied by 2 factorial, divide by 1 times 2 factorial. This will cancel this, so we have 3 here. Then x to the power of 1 is x. Negative 2y to the power of 2 will give us 4y squared. Then let us take the like term. Already 3 combination 3 is 1. X to the power of 0 is 1 also, so we only have this. Negative 2y to the power of 3 will give us negative 8y to the power of 3. So we have negative 8y to the power of 3. Let's break it down for the last time. This is equal to x to the power of 3 plus. Okay, this will become negative because of this negative sign. We have 3 times this negative 2, that will give us negative 6. And we have x to the power of 2, then y to the power of 1. We have plus sign. 3 times 4 is 12, so we have 12xy. And lastly, we have minus 8y to the third power. So this is just the expansion of x minus 2y to the power of 3. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Subsequently, we are going to look on to how to find the n term of binomial expansion using this combination. Bye bye.